Having discussed one unwanted issue with circuits, the problem of parasitics, let's look at another one, the problem of noise. Electrical noise is a technical name for the hiss which you hear when you turn up your audio amplifier on your CD player, for example, too high, or when you listen to the gap in between radio stations on an FM or an AM radio. It is an unwanted random signal present in all practical circuits, and is a major issue because once you have taken all possible steps to reduce it to a minimum value, the noise that remains, which is called the noise floor of a circuit, defines the smallest signal that you can detect. This wanted signal must be larger than the noise in order to be detectable. There are several important sources of noise, but one of the most important is that due to the random movement of electrons in conductors caused by heat. This is called thermal or Johnson noise. What we perceive as heat is actually just a random movement of particles. For example, the air around us is warm because the oxygen and nitrogen molecules within it are moving about in random directions and bumping into each other, and also bumping into anything else which is in their way. Temperature is just a measure of the average speed of the particles. The higher the temperature, the faster on average the molecules are moving. And a temperature of absolute zero is a temperature that they stop moving altogether, and therefore the lowest achievable temperature. Similarly, electrons in a wire move about randomly for exactly the same reason. They're hot. But each little movement generates a tiny random current because the electrons carry charge. This is the origin of electrical noise. The RMS Johnson noise in a circuit is given by the equation shown on the screen. As you can see, it depends on temperature and the resistance of the circuit and the bandwidth of the circuit. As I mentioned previously, Johnson noise is not the only type. Another example is one called short noise. Short noise is caused by the random way in which electrons jump across a barrier caused by two different materials joined together. When we are calculating the total noise in a circuit, we need to take account of all these different sources and add them together. We'll look at the subject of noise in more detail in the course later.